Let us begin with question number 3 on projection of lines. So here is the question. Question is like this: a line AB 70 millimeter long. So for a line AB, the length is 70 millimeter. So this clearly indicates that 70 mm is the true length of the line. It is the true length. Has its 1 and A on both the reference plane. So the first data is line AB 70 mm long. It means true length is 70. So we'll write down here. In capital we write data. And data should be written one below the other. So to underline and write TL equal to 70. No need to write millimeter. Now they have said point A is on both the reference plane. So we know that this is VP, here we have HP, and point capital A lies on both the reference plane. It means the front view of the point A dash and top view of the point A both are on XY. So when you rotate this down, A and A dash will have no effect. It will still remain on XY. So we can write small a on XY and even A dash is on XY. Okay, that is the meaning of front view and top view lies on the reference plane, both the reference plane. Next, proceeding further, it's mentioned that the NB is 35 above and above HP and 50 millimeter in front of VP. So if a point is above and in front, it implies it is in the first quadrant, and in first quadrant front view is above and top view is below XY. So NB is 35 and 50 in front. So if we go through this data once again, capital B is here. They are saying that it is 35 above. So this dimension is 35. And the another dimension is 50 in front. So when you look at the front view of this point B, the front view of the projection fall here called as B dash. And when you view from the top, the same point is B. So if a point is 35 above, it means opposite to that, even this will be 35 because both these are parallel. If a point is 50 in front of VP, so you can see it from top. So this dimension will also be 50. On turning this plane down, B will go down by 50 millimeter and B dash will remain up by 35. So to start with this, what we can say, point B. So B dash is here. So B dash equal to 35. So B dash is 35 above XY and B is 50 below XY. So always write in terms of XY over here. Last was what they've asked is, for question number 3, they have said draw the projection of the line AB. So projection means to draw front view and top view and find its inclination with HP and VP. So they've asked us to find out the angle made by the line, the actual line with HP and VP. So it is theta and 5. So we need to find out theta and 5. Okay. So you can look here, point A is well defined. Also B is well defined. So here there is no need to assume that the line is in first quadrant or second or third, not required because it is well defined. And as we have seen, always mark the position data first. Okay, so let us begin. So starting with aligning the roller scale with the edge of the paper, we will slide this down, and first of all we will draw a medium dark XY. Okay, so let us draw a medium dark XY. It should be medium dark. We will write capital X and Y approximately in the center of the line. Now always mark the position data first. So the first position data is, we will assume that point A is fixed and B is the moving point. So we need to draw locus of moving point, and the fixed point will have no locus. So A dash on XY. So mark a point, the fixed point, and write A dash here and A here. No problem. You can write in the same line also. So we have marked A dash and A. Now B dash is 35 above. So as we discussed before, we don't know right now exactly where is B dash, but it is 35 above. So we can move up and draw a light line locus where we can draw locus of B dash. Okay, so B dash is 35 above. So let us move vertically above by 35. So I'll align this roller scale, and from here, okay, let me mark a point 35 about 10, 20, 30, 35, and it is 50 below 10, 20, 30, 40, 50 below. So we'll mark both the points together. So B dash is 35 above, B is 50 below. So we can at least draw a locus because we don't know right now where exactly B dash lies. So aligning the roller scale, we will move up and draw a light line, and aligning the roller scale again, we will move down and again draw a light line, okay, in opposite sense. Okay, so we have drawn two locus. Above the locus, standard way, above the locus, on the extreme right side, you can write capitals locus of B dash. Please remember, on this locus, 2 points should compulsory lie. B dash, B1 dash. And here you have the next locus, so always write above the line, this is locus of B. The 2 points which compulsory lies here are B and B2. B and B2. So that is how we have plotted all the linear data. But as I told you, in projection of lines, you have to only show horizontal and vertical dimension. Inclined dimension need not be shown. So we need to show 35 and 50 over here. So from here, we can draw a light line. And we can write 35 above the line and along the line, and 50 over here. So as per orthographic, this is called above the line. So that is how all the linear data is being plotted over here. Yeah, sorry you were not able to see. So I marked 35 above and written locus of B dash, and below it is locus of B. So that is what we have done. So which is the only data left? So the only data left is they are given true length 70 and we need to mark that. So how will you mark 70? Let us try to understand. So if we go back to the tools, these are the tools here. So true length is at two different positions. A dash B1 dash is the first true length, and where does B1 dash lies? On the locus of B dash. A B2 is the next true length. Where does B2 lies? On the locus of B. Both the lengths should be same. True length always remains same in both the views. So true length never changes. Okay, so for marking true length, you need A dash and A and two locus. For the given question, we have A dash and A, and also we have the locus. So what one can do, you can set 70 in the compass, and from here cut on this locus, you will get B1 dash. And with the same point, because A dash and A are same, you can mark A B2 over here. So let us set in the compass 70 millimeter. So I will just turn the compass upside down. Sorry, not compass, scale. I will turn the scale upside down and I will set 70, that is 7 centimeter. But we used to talk in millimeter always. So this is 70 here. Okay, so I have set 70. And from A dash, cut an arc here on the locus of B dash, and this arc should be as small as possible and light. No need to draw a long big arc. A small arc just to make it visible is sufficient. So we know that on locus of B dash, this point has to be B1 dash. So write B1 dash above the line, along the line, and this point is B2. So if I join A dash with B1 dash, I will get the true length, which should be medium dark. So let us draw a medium dark true length. And write above the line, along the line as TL. Similarly, if I join A with B2, if I hide this, if I join A with B2, I am going to get the next true length, which will be medium dark. So here coincidentally A dash and A are the same point. So I'll write TL above the line, along the line. So write in this direction. So in the question they have asked you to draw projections. So draw projection means you have to draw front view and top view of the line. They have also asked you to find theta and phi. that can be done easily. So you can find theta, you can find phi. So what most of the students do is that they don't read the question. For example, here they partially read the question as find theta and phi, and they feel that the job is over. They forget to read this part, that is draw projection of the line AB. It means you have to draw front view and top view of the line. So this is not sufficient. This is not the final answer. So how will you get the final answer? Let us go back to the tools. So the tool says if you have A dash B1 dash, do not rotate. So you need to project, but till what level? Till the level of A. So A dash B1 dash should be projected till the opposite level, that is A, and then if you rotate to cut the locus of B, you will get top view. Or the other way around, if you have A B2, you should never rotate true length, remember, because logic says that if you rotate true length and project, you will get a line which is longer than the true length, which is not possible. So true length should never be rotated, but it should be projected till the next level. So by mistake, student what they does, they project B2 only till A and then they rotate. So carefully observe the tool. You have to project B2 till the level of A dash, and then you rotate to cut the locus of B dash. So apply any one of the tool to get the final answer. So I'll keep this besides. So let us apply tool number 1, which says that if you have A dash B1 dash, yes we have, project B1 dash not till level of A dash, further down to level of A. So when you project B1 dash here, you need to project till the level of A. So here coincidentally A dash and A are on XY. So we can project B1 dash, okay, till the level of A. Yeah, so we have done that. So after you project B1 dash till the level of A, this line is called as plan length and the point is B1. So develop a habit of writing PL. So after projection, this line is called plan length. So this is a coincidence that everything is on XY. It may not happen always. So you have to project till level of A. That is what we have done. And this point is B1. Okay, now the tool further says if you have plan length A B1, what you should do? You should rotate plan length. Do not say down. The correct statement is rotate plan length to cut the locus of B. So rotate this plan length to cut the locus of B. So take this plan length in the compass and rotate to cut the locus of B. So by doing that, this point what you get as per the tool is point B, and B should be joined with A to get the top view. So this point what we are getting here is B, and B should be joined with A dark so as to get the top view. So let us do that. So you can see a dark line. This is the top view of the line. So once top view is ready, we need to get front view also, isn't it? It's quite obvious, front view is required. So to get front view, there are two options. Number 1, operate the next true length AB2. So if I operate AB2, the tool says project B2 till the level of A dash. So we'll project B2 till the level of A dash. And then this elevation length you have to rotate to cut the locus of B dash. So that elevation length you have to rotate to cut the locus of B dash. But we won't be spending time by operating the next tool. Instead, we will apply orthographic rule which says that top view and front view always falls one below the other. So see, A dash and A coincides. So similarly, when you project B till the locus of B dash, you will get B dash. So simply you have to project B because ortho says front view and top view falls on the same level. So I'll align the scale with the edge of the paper. Okay, here I may go out. So from B, I'll project up to cut the locus of B dash. So wherever it intersects B dash, name that point as B dash and join B dash with A dash dark because that is the front view of the line. So this is the front view of the line, make it dark and write FV above. So that is how we have completed the question. Now they've asked you to find theta and phi, but remember that what I told is you have to compulsory show all the angles. So this is theta, this is alpha. So front view always makes alpha and theta is the true length. Do not write the values, just have to indicate that what are the standard notation. So here this is 5 and this angle is beta. Isn't it? So the drawing part is over. Now we need to measure theta and phi and write down below. So let us measure theta and phi and write down the answer in standard format. So I'll keep the protractor here, and if I measure, theta is approximately 30 degree. Okay, and on the downward side, if I keep the protractor like this, and if I measure 10, 20, 30, 40, this is approximately 45 or 46. Okay, so whatever answer you get, you may write. So plus minus 2 degree error is allowed in case of angles. So theta is approximately 30 degree and phi is coming out to be 46. So whatever you get, you have to write down and enclose this neatly inside a box and write down this is the answer. So very important to score 1 mark here. Before you proceed on, if I want to verify in the exam whether this answer is right or wrong without asking our neighbors or peeping into the WhatsApp, what is the other technique? What we'll do is that we have front view with us. We will rotate front view till the level of A dash and project to get B2. So if this front view is rotated till the level of A dash and if you project, it should match B2. So what one can do in the exam is you can take A dash to B dash in the compass. So if you operated one tool, then you can use the next tool to verify. So I have taken A dash B dash in the compass. Now very important, do not show rotation because you already solved the answer. Do not show rotation, just mark a point in level with A dash. So I marked the point here. See, this is that point. You need not highlight in the exam. Then align your scale with this straight vertical line. Move back. And when you project down, this almost matches with B2. Okay, with a very small error. That is okay. So plus minus 3 mm error is allowed, we know. So this projection will almost match. Okay, so that is the way you can verify your answers. Let us now begin with question number 4. The front view and top view of a line AB measures 50 and 60 respectively. So they have given the front view length and top view length, which is 50 and 60 respectively. So here we can write in the data. Okay, so in the data you can write FV, that is front view, equal to 50. Below that top view equal to 60. So these lengths are given. The line AB, further, the line AB is 70 mm long. So if you compare these three lengths, 50, 60 and 70, it is very clear that true length is the longest line. So the line AB 70 mm long has to be the true length because these are the three lengths what is possible here. So true length equal to 70 is the third data. Okay. Next what they have said is the endpoint A is in first quadrant and equidistant at 20 mm from both the reference plane. So point A is said to be in the first quadrant and at equal distance from both the reference plane. So what we should do here is, so if you look here, so this is our XY line. Point A is in the first quadrant, that is above HP and in front of VP, and 20 mm from both the reference plane. So here reference plane means what? VP and HP. They are called as the reference plane. So it is 20 mm away from both. So if this is capital A, this is 20 in front and 20 above. So here you will get A dash and here you will get A. So when you turn HP down, it's very clear that A dash will lie 20 above XY and A will lie 20 below XY. So we'll write down here A dash equal to 20 above XY and A is equal to 20 below XY because it is in the first quadrant. Okay, so this part is clear. So if you always count, you will find 5 data are ready. Okay, what is the next part they've asked is? Okay, so in question number 4 they've asked draw the projections. So again you have to draw front view and top view of the line. Find the inclination of the line with HP and VP. That means they have asked theta and 5. So draw projections. Apart from that, they have asked you to find theta and 5. Now carefully examine the the data that is called as the position data. So here in the question, they have mentioned only about A. So point A is well defined. What do you mean well defined? Well defined means the distance of A dash from X, Y and A is known. But they have not mentioned anything about B. They have not mentioned anything about B. So what one can do is you can either draw a flower bracket or draw a line and write down assume. Besides you can write down assume B in first quadrant. And this is not sufficient. Below that you should write down B dash above xy and B should be below xy. So the data has to be written like this. This is our assumption. Actually B can be in any quadrant, but for our simplicity we can write B dash above and B below xy. Okay, so as we have discussed, we should always mark position data first. Okay, so let us do that. So in continuation with the previous xy line, let me draw a medium dark xy here also. So I will write capital X and capital Y. Now the position data is A dash is 20 above and A is 20 below. So I'll align the roller scale here. I will slide. So A is our fixed point always. Now we need to mark 20 up and 20 down. So 10, 20, here there's a point, and 20 down, here we have the next point. So this point, write A dash above and on the left side, and this point is small a below and on the left side. Okay, so don't forget to show dimensions. Okay, we need to show dimensions now. So extend, so this xy, from A dash draw a medium dark extension line. From A also draw medium dark extension line. From here, draw the dimension line. Show neat arrowheads. And write 20 on each side. Correct? So we have marked the position data, that is A dash and A. So that is already marked. So both these data are ready. So as we discussed that we are assuming B dash is above. Let me roughly write down that B dash is here so that I can remember while rotating or projecting. And B is down somewhere here. So I will just mark B somewhere here down. Okay. So now what will be the next step? Let us understand. Now the problem with this question is, in the data there are three lengths, front view, top view and true length. But the tool says if you want to draw front view length, the front view lies on alpha, so alpha is not given. Top view 60 mm, so as per the tool, top view lies on beta and beta is also not given. And as far as true length is concerned, it lies on theta and 5. So you have to remember that this is a case where all the lengths are given but corresponding angles are not given. So how are we supposed to go with this? That is the question. So what is given? A dash is given, A is given, A dash in A is given, true length is given, front to top view is given, but all the angles are missing. Neither locus is given. So how will we proceed with this? That is the question. So to start with, what you should remember is front view. So if you look at this front view, it is also called as elevation length. And elevation, to draw elevation length, you don't need any angle, it's a horizontal line. Similarly, top view is also called as plan length. And to draw plan length, you don't need any angle, it's a horizontal line. So what one has to do is that you either catch hold of elevation length or plan length, any one of them, because if you take both, confusion will increase. Let us consider tool number 2. So if I want to draw elevation length which is equal to front view, then you need A dash, and we have A dash with us. So from here I can draw elevation length. So the problem was in writing the data. So when we started writing the data, you should remember that front view means elevation length. So if you could have written EL here, then thoda strike hota tha, okay, both are same. Similarly, top view is plan length, you should have written PL over here. So now EL and PL are horizontal lines, you don't need any angles. So let us take any one of them. So I will take elevation length. So from A dash, so elevation length says from A dash you can draw horizontal line. So I'll align the roller scale with XY, and from A dash I will draw a light horizontal line, and we are supposed to mark 50 on it. Okay, so let us mark 50. So here I'll mark 5 or 50, and don't forget to write EL on this, equal to 50. If you show proper dimension, then it will interfere with the diagram. So EL equal to 50 is sufficient. Now this point is B2 dash, so we can write B2 dash over here. What next? Once you marked EL, don't spend your time in marking PL. You play with this EL. So look at point B2 dash. B2 dash can be operated in two directions. You can rotate to cut locus of B dash, and you can project to cut locus of B. So both this you can also operate the tool in both the directions. So you can rotate to cut locus of B dash, and you can project to cut locus of B. So here I can take elevation length A dash B2 dash in the compass like this. Okay, and I can rotate, but I don't know how much to rotate. Okay, so just a second. So we don't have locus of B dash here. So what we can do is we can simply rotate and keep it as it is. So I'll just simply rotate. I don't know how much, but further you can also operate this elevation length in the another direction, that is project B2 dash to cut locus of B. So here we have B2 dash. You can project B2 dash to cut locus of B. So I can align the scale with the line, and from B2 dash I can project it down to cut the locus of B. So why I project it down? Because I am assuming B in the first quadrant, so B will lie down. Okay, so that is what I have done. I have rotated upward and projected downward. So how to proceed now? For that, go back to the tools. The tool says when you project B2 dash down, it should meet true length somewhere, and wherever this green and red line meets, that is your final true length B2. So see, we already projected this down. Okay, so I'll erase this B2. So as per the tool, when you project B2 dash down, B2 should lie. So B2 should lie somewhere on this line. And if I can somehow find true length, then the intersection will give me B2. So on this line, I need to cut true length from A, and that is given as 70. So from A, if I cut 70 on this projector, I can easily get point A. So here, let me take 70 in the compass. So I'll take 70 in the compass. Okay, and from A, I will cut on this projector. So this point what I got just now, that is point B2, isn't it? So B2 is ready. Now from B2, can we draw locus of B? Answer is yes. So I'll align the scale with XY, roll down, and from B2 we can draw a light line, and always write above the line as in capitals locus of B. Okay, locus of B. So where should I join this B2? So the tool says join B2 with A medium dark. So B2 is here and A is here. Join them medium dark. So right above the line TL. Okay, so what next? So again refer the tool. On locus of B, 2 points should lie, B2 and B. So if I join A with B, I'll get the top view. In the question they have given top view length as 60. So B should lie somewhere on this locus, and when you join A with B, we'll get top view. So top view is given as top view is given as 60. So in a compass, we will set 60. Okay, and from A, cut on the locus of B. So here you are going to get point B. On joining A with B, you will get the final top view of the line. And right above the line as TV. Okay, so I hope all of you can see this. Yes. Now proceeding with top view is ready, true length is ready. You have drawn a circular arc. So the tool says on this circular arc, B dash has to lie somewhere. So B dash will lie somewhere on the circular arc. Now we need locus of B dash, front view and the next true length. So one thing is clear, that B dash will lie on the circular arc, and as per ortho, top view and front view lies on the same vertical line. So if I project B, B dash will lie somewhere on this projector. So very simple. Project B to cut the circular arc, that is your B dash, because B dash lies both on the circular arc as well as on the projection of B, sorry. So I align with A dash and A, draw a light projector from B. So wherever it cuts the circular arc, that point is B dash, isn't it? So B dash is ready. So join A dash with B dash dark. This is your front view of the line. And if we get B dash, we can easily draw locus of B dash from here. So locus of B dash can be drawn easily, and we can write above locus of B dash. What we need next is the true length AB2, A dash B1 dash. True length A dash B1 dash is required. So how will you get that? So take this true length in the compass and cut it here. Okay, so erase this B dash, that is just an understanding. So join this medium dark and write TL above. So this point is B1 dash. And finally, as we know, we need to label theta, alpha. From here, we need to label 5 and beta. So this is 5 and this is beta. So draw projections is over. Now we need to measure theta and 5. So if we measure theta and 5, it comes out to be 30 and 45. So I like to tell all of you that the questions are intentionally designed so as to get theta 30 and 45. In exam, this might not be the case. So don't be tensed if you don't get 30 and 45. It depends upon the question data. But still you can verify by operating the next tool. See here, in this case you operated the front view, right? So front view was rotated. So if you want to verify your answer, you rotate the top view and project. It should match with B1 dash. That's all. We will now proceed with question number 5. But there are two parts, A and B. Right now we will solve 5B. So A we will see later on. Let us solve question 5B. So we will read the question and write down the 5 datas. What are those? Let us see. The distance between the end projectors of a line AB is 35 mm. So the first data is dBEP equal to 35. The end point A is 10 mm above HP and 20 mm in front of VP. So up till now it is clear that above and in front means first quadrant. So point A is 10 above. That means A dash is 10 above XY and A is 20 below XY. So that point is clear. Now you should read like this, and point B is at a distance of 40 mm from both the reference plane. What do you mean by reference plane? It is HP and VP. So point B is at a distance of 40 mm from both the reference plane and in third quadrant. You have to read like this. So it's written here point B is in third quadrant. So once again let us see. Point B is at a distance of 40 mm from both the reference plane and in third quadrant. So we need to see about third quadrant now. So if I plot the two planes VP and HP. So this is our VP, vertical plane, and horizontal plane is somewhere here. Okay, this is HP and the imaginary line is XY. So point B is in the third quadrant, it is somewhere here, and 40 mm from both the reference plane. So you should know by heart that whenever a point lies in third quadrant, it means the front view B dash will fall below XY, and after turning the plane B will be above, and it is 40 mm from both the planes. So this dimension is 40 and even this is 40. So that is how in third quadrant, after you turn the plane HP down, this has to go up. So B will go up above XY by 40 and B dash will remain down by 40. So the data will be like this. B is equal to 40 above XY, but B dash is 40 below XY. Okay, so that is how it's going to be. So it clearly says that this is a question on mixed quadrant. When I say mixed quadrant means one endpoint of the line is in one quadrant and another endpoint is in another quadrant. So how will the line look like? Let us see here. So I will again draw VP and HP. So we need to just visualize that if a line is in multiple quadrant, how will the line appear to be? So this is the XY line. Okay, so point A is in first quadrant and B in third quadrant. So suppose A is here and B is in third quadrant somewhere here. And if you look at the line by joining them, so this part, then I will show some portion broken just for your understanding, and then here. So that is how the line appears to be. So one point A in first quadrant, another point B is in the third quadrant. So the line cuts the quadrant, or you can say that the line cuts the plane VP. It comes out, it cuts the quadrant HP again and comes out from the other side. That is how the line appears to be. You need not try to visualize beyond this, it's not required. So only you have to understand that if a point is in first quadrant, the front view A dash has to be above XY and A has to be below XY after you rotate HP. And if a point is in third quadrant, the front view B dash will remain below XY after you rotate HP, and the top view B will lie above XY after you rotate the HP. So only these things you need to remember. No need to look in front view and top view and try to draw the planes over here. Let us see the further part. So point B is at a distance of 40 mm from both the reference plane and in third quadrant. What they was draw projection. So by now it's clear. Draw projection means you need to draw front view and top view and determine the inclination with HP and VP. So you need to find out the inclination of the line with HP and VP. So they've asked you to find theta and 5. Okay, so inclination with HP means true length with HP. Inclination with HP means true length with HP. And inclination with VP means true length with VP. So they are called theta and 5 when B is in third quadrant. Okay, so this is the given question. So you may count that total there are 5 data, 1, 2, 3, 4, 5, and you should be able to solve it. So to begin with, you should always mark the position data first. So these are the 4 position data what you need to mark. Okay, so let's start. So we'll first draw medium dark XY line. So aligning with the edge of the paper, I need to roll this back, and approximately in the center of the distance what is being left, we will draw a medium dark XY and write capital X and capital Y over here. Okay, so we have started with this. Next, proceeding with, we need to mark the position data first. So it's given here that A dash is 10 above XY and A is 20 below. Okay, 10 and 20. So let us consider A as the fixed point and B as the moving point. So fixed point will never have a locus, but moving point will have a locus. So A dash is 10 above and A is 20 below. So perpendicular with this, or you can align the scale with the end, roll back. Okay, so this is a little, we can do it from the other side. Roll back and draw a light projector of A. On this projector, we will mark distance 10 and 20. So I'll move up by 10, mark a point, come down to 20, mark another point. So this point is A dash, label it as A dash. This point is A, label this as A. Show dimensions 10 and 20. So from here when you slide up and come down, so here we can show dimension 10 and 20. So this is 10 and 20 is here. So the next position data is B is 40 above. Okay, so now there is a exchange offer. Instead of B dash, now it's B which is 40 above XY. So we don't know where exactly B is right now, but we can move up by 40 and we can draw locus of B. Similarly, B dash is 40 below. So from XY you have to come down by 40 and draw locus of B dash. Okay, so let us mark 40 up and 40 down. So from the scale we'll move up by 40, 10, 20, 30, 40. From here we'll come down by 40. And now aligning the scale with XY, we can roll up, draw a light line. This is the locus of B, not B dash. And coming down, so we are solving mixed quadrants. So in mixed quadrant, always there are changes. So above this line, we can write in capitals locus of B. Remember now it is B, not B dash. And over here above the line, we can write locus of, now this is B dash. So B and B dash are being exchanged. So on locus of B, the 2 points which you compulsory lie are B and B2. And on locus of B dash, the 2 points are B dash and B1 dash. Next step is to show dimensions. So all the horizontal and vertical dimensions needs to be shown only. Do not show inclined dimension. So here draw a vertical line and show 4 arrowheads. You have to show 4 arrowheads and write 40 here as well as here. Okay, so the last data what is being left is to mark DBP 35. After that, all 5 data are being plotted. You need to draw projections and find theta and 5. So DBP is the horizontal distance between projector of A and projector of B. So we have already drawn projector of A. Now we have to move 35 apart and draw projector of B. So from this point, XY, from XY and from the projector, we'll mark 35 millimeter. So mark 35 here. And then parallel to this projector of A, we need to roll back. And from here, we have to draw a light line. So this point is projector of B. We need to show the horizontal dimension DBP. Okay. So here we can draw a line. Okay, we can draw a line here. And we can show dimension DBP on this side. So dimensions always medium dark. So this is DBP equal to 35. That is what we need to show here. Okay. Now carefully observe, this is the projector of A, so the 2 points are A dash and A. But this is the projector of B, your 2 points should be B dash and B. So now you should be extra alert, it is a mixed quadrant. So wherever this DBP intersects the locus, these are the 2 points what I am highlighting. So because this point lies on the locus of B, so don't mark it as B dash by mistake, it has to be B. Because on locus of B, B dash cannot lie. Similarly on the same projector, this is B dash. So we have plotted all the linear data. Now it's time to understand the next part. So if we look at the tools, the tools will remain same. These tools are our guide to solve any kind of question. So make one thing clear, that A dash should be always joined with B dash irrespective of the quadrants. So if a line lies in mixed quadrant, still A dash has to be always joined with B dash and A should be joined with B. So here A dash is here and B dash is down. So you need to join A dash with B dash dark but downward. A is here and B is here. You need to join them with a dark line. So let us join the lines over here. So I will join B with A. I will double trace it and make it darker. And I will join A dash with B dash. Double trace and make it darker. So this AB is called as top view of the line. So right above and along the line as TV. A dash B dash is the front view of the line, right above as FV. So that is how we have plotted all the data. Draw projections, that part is also done. So we cannot end our question here because they have asked theta and 5, which is nothing but the angle made by true length with HP and VP. So if you have front view and top view and if you need true length, the tool says you can easily do that. How to start? Okay. So let us revise the tools. Now what is the difference here? Let us see. See, this is the top view. So strictly follow the tools. Top view is AB and here top view is AB on this side. Try to compare. By comparing you will get it very easily. So top view AB is here, but here the top view is on this side. So irrespective of the quadrants, what does the tool says? Keep point A fixed, rotate B till the level of A. Same thing you will be doing here. We'll keep this point A fixed and we'll rotate B, but we'll not stop here. We'll rotate B till the level of A. So I'll again repeat, as per the tool, you have to rotate B but till the level of A. Same to same you have to do here. Rotate B till the level of A. So you have to stop here. Once you reach there, you'll get plan length and B1. So once you rotate B till level of A, you'll get plan length and B1. What next? After you get B1, you should not by heart project up. No. Project B1 to cut the locus of B dash. Project B1, this is the correct thing. Project B1 to cut the locus of B dash. So after you rotate the top view till here, project this to cut the locus of B dash and you'll find locus of B dash is down. So project down. So this point is B1 dash. So by mistake, if you by heart project up, you'll move up only. Then you'll get a wrong answer. So rotate top view till the level of A. Project to cut the locus of B dash, you'll get B1 dash. Now B1 dash should be compulsory joined with A dash. So join this B1 dash with A dash. Where is A dash? It is above. You get the true length. Okay. Now if if a student wants to operate front view, then what can be done? So here you have a dash b dash, and see a dash b dash is here. So keeping point a dash fixed, rotate b dash to the level of a dash. Do the same thing. Rotate b dash, do not stop here. Level of a dash is above. So rotate b dash till the level of a dash. You will get elevation length here. Here you will get on this side. You will get b2 dash as per the tool. Now don't say that project b2 dash down. Then you should say project b2 dash to cut the locus of b. Here locus of b is above. So project it above. You will get b2. b2 should be joined with a. So a is here. Join b2 with a. So operate any one of the tools and complete the answer. Okay, so let me operate tool number 1. Okay, I'll operate tool number 1. It says that rotate top view till the level of A. So let us do that. So I will take top view AB in the compass. So you have to always operate any one tool. Don't operate both the tools, not required. So we'll operate top view till the level of A. So most of the students, they stop here because they have in their mind you have to project till A dash. So you should always rotate till that level from the center of rotation. So center of rotation of top view is here, where the needle is. So you need to rotate top view till the level of the needle, or you can say till level of A. So you have to stop here. Okay, so till the level of A you have to stop somewhere here. To get the exit point, you need to align the roller scale, roll up till the level of A. So you have to stop rotating over here. So when you rotate top view, as per the tool, you will get planned length. So name this as PL. The name of the point is B1. Same name you have to give here, B1. Now further the tool says project B1 to cut the locus of B dash. So this you have to search where is B dash first. Okay, it is down. So project it down to cut the locus of B dash. So from here, aligning the scale, roll it, and project B1 to cut the locus of B dash like this. So wherever it intersects the locus, that point is B1 dash. Now be very careful. By mistake, students join B1 dash with the nearest point A. So you have to strictly follow the tools. B1 dash should be joined with A dash. So come that to medium dark. So join B1 dash with A dash and medium dark. So from B1 dash, I will draw a medium dark line. So this is our true length. To write TL here. Okay. Now the question is, you got one true length A dash B1 dash. How will you get the next true length AB2? So as we know that true lengths are same always. So take this true length in the compass. Okay, so next true length is what? AB2. So A is here. And where will be B2? On the locus of B. So once you get the true length, take the same true length in compass. Okay, and from A, cut an arc on that locus. So wherever it intersects that locus, that point has to be B2. Join B2 with A medium dark. And you'll get the next true length. So after we have drawn both the true lengths, we need to mark theta, phi, alpha, beta. Okay, so you should remember that this top view is always beta. So top view is beta but with horizontal. So see if I give the naming over here, this is quite congested. So one more option is that this locus of B is horizontal line and this is the top view. So even the angle can be named here also. So top view makes always beta with horizontal. So we can write beta here. Beta and phi are best friends. So this true length AB2 is 5. So this phi is also with horizontal. So we can name here 5. Okay, now this front view makes alpha with horizontal. So we can name alpha on this side. And this true length is theta with horizontal. You can write theta over here. So we have named all the phi angles. Now they've asked us to measure theta and phi. So if I keep my protractor here, and if you measure this angle, it comes out to be 45. So let me check it here. So this 5 is 45 and theta is not 30 this time. So theta is 35 and 5 is 45. Okay, 5 is around 45 or 46. So we can write down the answer below the locus. So you can write theta equal to 35 degree and 5 is equal to 45 degree. You can enclose this within a box and write answer besides. So this is the complete answer and this is the method to solve. So what is the technique to solve? Always write data one below the other. Then solve the question with proper line selection. Nature of line should be correct, light, medium, dark, dark, and answer should be beneath. Okay, only then you'll get full marks. Let us switch over to question number 6. A line AB 100 millimeter long. Okay, so line AB is 100 millimeter long. So if I write the data on this side, so as per the data, question number 6, true length TL equal to 100 is inclined at an angle of 30 degree to HP. So true length is inclined at 30 to HP. That implies theta is 30 degree and 45 VP. So 5 is 45 degree. Its endpoint is 10 above HP and 20 in front of VP. So standard data, point is 10 above and 20 in front. It is the first quadrant. So A dash is 10 above X5 and A is 20 below X5. So 5 datas are done. If we proceed further, draw the projections when point B is in third quadrant. So whenever a point is in third quadrant, what you should write here is B is above X5. So top view is above X5, we know that, and front view will be below X5. Also find the position of point B from HP and VP. So a new thing is been asked, position of B, but from HP and VP they have said position of B from HP and VP. Okay, so this is what they have to find. Also they have said draw projections, so you have to draw front view and top view of the line. So these are the data what is given. Okay, so to begin with, let us first draw a medium dark X5 parallel to the edge of the paper. So I will roll this down and approximately in the center of the distance what is left, or in continuation with the previous line, let me draw medium dark X5. So I'll write capital X here and capital Y on this side. Okay, so X and Y is ready. Now always mark the position data first. So we'll keep point A fixed and let B be the moving point. So locus is valid for fixed point only. So let us mark 10 and 20. So I'll align with this and roll further. And we'll mark 10 and 20. So I'll move up by 10 and 20 down. So this point is A dash and A. So quickly mark A dash and A on this side. And show dimensions 10 and 20. For that, align with XY, move up, draw a light line, come down, draw one more extension line. From here, move behind. And here we need to mark 10 and 20. So here you need to mark 10 and we need to mark 20 on this side. Okay. So after 10 and 20, after we have marked A dash and A, we know that B is above. So roughly for my reference, I'll just write B here, so that in case if I rotate project, I should know that B is here and B dash is somewhere here. So these are not the final points. This is just the position to make you aware that where you're supposed to mark and draw. So A dash is done, A is done. Now theta, on theta and phi, we used to mark true length always. Let us deal with theta first. So go back to the tools. Okay, now if you look at this theta, theta is a line connecting A dash with B1 dash. And B1 dash lies on the locus of B dash. So theta starts from A dash and A dash is here. Isn't it? But it should be drawn towards locus of B dash. And locus of B dash is down. So instead of marking theta up as you're doing regularly, you need to mark theta down on this side. So if you align the XY line, and if I draw a light line just for a reference to mark the angle. So from A dash, you need to mark theta down because locus of B dash will lie down. And the tool says always mark true length, always mark theta towards locus of B dash. So this is the protractor here. You need to keep the protractor in a reverse direction and count from 0, 10, 20, 30. Mark 30 here. And draw a light line on connecting A dash with this point, what you mark 30 degree. First we'll draw light. Now on this true length, on this theta, always you need, on this theta, we always need to mark true length 100. So here by scale itself, no need of compass, you can mark 100 and draw medium dark line. So this is your true length. Okay, we need to erase the additional line that is being drawn to avoid confusion. So true length ends here, right above the line, along the line as TL. No need to write 100. So once this point is ready, you should remember the name of the, try to remember the name of this point. It is A dash B1 dash. So call this as B1 dash. Now once you locate B1 dash, we can immediately draw locus of B dash. So for parallel to this XY line, we will move down, and from here we'll draw a light line, and above this line in capitals we will write down capital locus of, which should be capital, and B dash should be small. B dash should be small. Now similarly, in the question they are given this as 5. So 5 is 45 and true length is 100. So as per this diagram, this is the angle 5. So 5 is a line connecting A and B2. So A should be drawn towards locus of B. That is what you have to remember. So A is here and locus of B is somewhere above. So you need to draw 5 upward, opposite. Up till now you are drawing 5 down, right? But now it should be in the upward direction because of the change of the quadrants. So I will need to mark 45 here and connect this A light with that line and mark true length on this, because true length always remains same for both theta and 5. So from here I need to mark 100 millimeter true length, and this portion we need to draw medium dark. So this is the true length TL. Okay, so according to the tool, this point is B2. So we will write B2 over here. So once B2 is ready, we need to draw locus of B passing from B2. So I'll align the scale with XY. I will roll it, and from B2 I'll draw a light line and we'll write above the line as locus of B. So you need to be very thorough with the tools, that on locus of B 2 points should compulsory lie, B and B2, and on locus of B dash 2 points should lie, B dash and B1 dash. Those things should be clear. Okay, so I hope this part is done. Now once this is done, we need to find, in the as per the question, position of B, so that we can do later on. They've asked draw projections, so we need to draw top view and front view of the line. So because you have two true lengths, you can easily find them. How? Let us take any one tool. So let us take tool number 2. So as per tool number 2, if you have true length AB2, so remember true length should never be rotated. It should be projected till the next level. So you should be very thorough with this tool. So if you have AB2, project B2 but till the level of A dash. Project B2 till the level of A dash. So again AB2 should be projected till the level of A dash. Same thing here, A is here, B2 is here. So project B2 till the level of A dash, and A dash is somewhere here. That's all. So from here I will draw a light line B2, but not throughout, till the level of A dash. You need not erase extra line if drawn. So see, once again compare this with the tool. Yeah, compare this with the tool. So what does the tool says? Project AB, sorry, this one. Yeah. So the tool says, so here project AB2. So project B2 till the level of A dash. Same thing you have to do. This is A, this is B2. Project B2 till the level of A dash, and you have to stop here. So as per the tool, the name of the point is B2 dash. So we have to name B2 dash here. What is A dash B2 dash called? A dash B2 dash is called elevation length. So we should write EL. Now further the tool says, if you have elevation length A dash B2 dash, rotate B2 dash to cut locus of B dash. So don't say rotate up or down. You have to say rotate B2 dash to cut the locus of B dash. Where is locus of B dash? Down. So this line EL, B2 dash you need to rotate to cut the locus of B dash. So here B dash is down. So take A dash to B2 dash in the compass. We'll take A dash to B2 dash in the compass. Okay, and we will rotate B2 dash down to cut the locus of B dash. So this point is B dash. Okay, so tool is our, you can say, godfather. If you are thorough with that, you can solve any question on line. So now where should B dash be joined? So as per the tool, you have to join B dash with A dash dark so as to get the front view length. So B dash is here and A dash is above. Join them dark so as to get the front view length. So double trace, make it dark, write FV above the line. Now all of us know that if front view is ready, you can get top view very easily by projection. So A dash and A lie on the same line, so B dash and B should also lie on the same line. So we need to project B dash to cut the locus of B, which is above. We'll get B from there. So align with the here, project it up. Okay, so this point is B. Again, as per the tool, B should always be joined with A, and that too dark. So join B with A is down, and that too we need to draw dark. Okay, and AB is called top view of the line, write TV above. Once this is done, we need to name the various angles. So top view with horizontal. So this place is congested again. So we can name it here, top view with horizontal. Even if a student names it, it's not wrong. Okay, you can name here also. So top view with horizontal is called beta. And this true length is called as 5. AB2 is called as 5. Front view with horizontal is called as alpha. And this true length is called as theta. Now they've asked us to find position of B. So in which quadrant B lies? See, very clear, position of B from HP and VP they've asked. So B lies in which quadrant? Third quadrant. So how to define a point in third quadrant? Let us write down first. So you have to answer the question like this. Point B. Okay, let me write down here. How to answer the question. So this is the answer. You should write like this. Point B is. Now when a point lies in third quadrant, what we used to say is it lies below HP and behind VP. So point B is dash how much? Below HP and dash behind VP. So you need to write with respect to HP and VP as it is asked in the question. Okay, so how will you find out how much it is below and how much it is behind? Okay, so for that you need to understand the diagram. So if you look at the third quadrant alone, so let me draw the third quadrant alone. So this is the third quadrant. Point B is here. So front view, this is what? B dash. And this is nothing but locus of B dash. So if you can measure locus of B dash from XY, you will get how much it is below HP. Similarly, when you look in the top view, projection of B falls here called as B, and this is nothing but locus of B. So this is nothing but locus of B, and if you measure this distance from XY, this is called as behind VP. So locus of B dash means below HP. So for your reference, I'll write down here, below HP means in bracket locus of B dash, and behind VP means you need to measure locus of B. But from where? From XY. So let us remember this. Let us do that. So if I take a scale and measure locus of B from XY, so let us measure this from XY, it comes out to be 50 millimeter. So 50 millimeter, the point is below. So what by mistake student do is that, okay, so once again, locus of B dash means below XY, you have to measure below HP. So below HP is here. So point B is 50 below HP. Okay, there's a small mistake from my side. I will erase this 50 here. Okay, so point B is how much below HP? So below HP means you have to measure B dash, and sorry, B dash is down. So you need to measure this distance. So it comes around 40. So don't write 4 by mistake. This is 40 below. And behind VP. Behind VP means you have to measure locus of B from XY. And locus of B is somewhere here. And if you measure from XY, it is 50 millimeter. So it is 40 below HP and 50 behind VP. Okay, or you can say B dash means below HP, so you have to measure this. So are you aware that anything below XY is HP, isn't it? So you have to measure B dash from XY, which is 40, and B is 50 above. Okay, so that's how we have answered this question. So whenever they say find position, you need to write the statement like this. Point B is 40 below HP and 50 behind VP. So below HP means locus of B dash, behind VP means locus of B.